Hi everyone, in this video we're going to talk about analyzing functions. So the first thing we're going to do to analyze a function is talk about even versus odd. An even function is a function that is symmetric about the y-axis. So to be symmetric about the y-axis, that means there's going to be a mirror image about the y-axis right here and right here. So if I were to fold this graph in half along the y-axis, everything on the left would match everything on the right. Another thing to know about even functions is the y-axis symmetry goes for points as well. So if I had the point 1, 1, then on the other side, I'm going to have the negative version of x, and my y value is going to be the same at positive 1. So notice how they share a y value. Same thing goes here. I have a point here at 2, 4, which means I'm going to have another one at 2, negative 4, because they are, not 2, negative 4, I'm sorry, negative 2, positive 4, because they are symmetrical. Okay, same thing happens on this absolute value function that we have. So if you notice here, I got a point at negative 2, 1. Then I'm also going to have a point at 2, positive 1, because they are symmetrical. Looking over at the next part, odd functions are symmetric about the origin. Okay, so odd functions are symmetric about the origin. The origin is the center of the graph right here. Okay, so basically what this is saying is if I were to reflect this down here and then reflect it over here, it's going to line up. It's going to be the diagonals that match. So anything that's here is going to line up with anything that's there. Anything in this quadrant would line up with anything in this quadrant. Okay, now as far as the points go, if I have the point 1, 1, an odd function is going to be the exact opposite for both my x and my y value, which means I now have the point negative 1, 1, negative 1, which is how we know that it is an odd function. Same thing happens here and here. So we have 1, 1 here. Here we have negative 1, negative 1. And this goes for every x and y value on the graph. Okay, so the math behind it is to be even. If I plug in a negative value, then I'm going to get the same y value that I started with. An odd function, if I plug in a negative value, I am going to get the exact opposite of what I started with. Okay, so that is the math behind even and odd. But what we're going to focus on is that even functions are going to have all even exponents. So 2, 4, 6, 8, 10. But they are allowed to have a constant. A constant is a number without a letter. So when we see one, I will make sure that I point it out. And an odd function is going to have all odd exponents. Okay, and they are not allowed to have a constant. So if we want to determine if the function is even, odd, or neither, we're going to check for its exponents. So if we look at this first one, I see that I have an exponent of 2. I know that that is an even number. And this right here is a constant. If we look back up at the first bullet, even functions are allowed to have a constant. That's an even exponent. So this is an even function. And it's going to have y-axis symmetry. looking at the next one, I see that I have an exponent of 4, but then I have an exponent of 3, and then I have an exponent of 2. So I have some even exponents, and I have an odd exponents. Okay, my two rules said I either have all even or all odd. In this case, it's a mix, so therefore this has neither even, or it's neither even or odd, and it has no type of symmetry. I move to the next one. I see that I have an exponent of 5. I have an exponent of 3. They're both odd. There's no constant, so we're good. And that's going to be an odd function. With origin symmetry. Looking at the next one, I see that I have an odd exponent, but I also have a constant. So because there is a constant with an odd function, it cannot have any type, or it will not have odd symmetry. So this is going to be another neither with no symmetry, because again, it is an odd exponent with a constant, and that was bullet number 2. It cannot have a constant. Okay, the last part, oh nope, not the last part quite yet, but now we're going to talk about the extrema. The extrema is talking about absolute minimums and maximums and relative minimums and maximums. So the absolute maximum is when it is absolutely the highest point or the lowest point on the graph. The relative minimum and the relative maximum is a point on the function that is higher than all the points that are immediately surrounding it. So it can be also lower if it's a minimum. So if I look at this graph right here, this point right here is a minimum. But it is not absolutely the minimum because there's another point that is lower than it, which is this one. So in this right here, this point is a relative min because it is relatively lower than any point right here or here that's immediately surrounding it. Okay. This point right here is also another relative min, but more exact, it is an absolute min. Because it is absolutely the lowest point on the graph. There's no point on this graph that goes below right here. Then we have this point that's in the middle. This, okay, I know we want to think that it is an absolute max, but it's not an absolute max because this part of the graph, anything here is taller than it. So it is just a relative max. So that's the difference between an absolute and a relative. Now, another name for a relative, min or max, could be local. Sometimes the word local is thrown around. And another name for absolute is going to be global. Okay, so those are words that also mean absolute and relative, just in case you happen to see them. Okay, this piece right here is saying finding a min or max means that we're finding the y value of the point. The min or max is always the y value because it's telling us the minimum or maximum value. In the real world, it's talking about the highest earning potential. So we want that, whereas the X value is the location, or it tells us how long it takes to get there, but it is not that min or max value. So what I would like you to do is to pause the video and try this example right here. So hopefully you gave this a try, but it wants us to know if there is a relative or absolute min or max at x equals 0. So x equals 0 is right here. It is a maximum point, but it is not the highest point on the graph because we have parts here and here that go higher than it. So this is a relative max. Okay, so it is relative and it is a max. Just to keep going with it, this point right here is a relative min. I'm going to abbreviate relative on this one. And then this point right here is an absolute min, and I'm also going to abbreviate that just so you can see. Okay. The last part of this video, we're going to talk about end behavior. So end behavior is describing what happens at the ends of the graph, the tails of the graph. So we have a left side end behavior, and then we have the right side end behavior. So the left side end behavior is as x approaches negative infinity. So as my x values go this way towards negative infinity, what is the y value of my graph doing? Because remember, f of x equals y. So my y values down here are going down as well towards negative infinity. So as x approaches negative infinity on this graph, y also approaches negative infinity. Then I have my right side end behavior that says as x goes towards positive infinity, so positive infinity is going this way, what is my y values doing? My y values are also going up towards positive infinity, so that's what goes in this blank. So just to see that on another graph, let's look at this one right here that I kind of wrote on. So I'm going to go ahead and add the statement as x approaches negative infinity, f of x approaches blank, and then as x approaches positive infinity, f of x approaches blank. The arrow means approaches. So as my x values go towards negative infinity, what is my y value doing? It's going up. Since it's going up, that means it's going towards positive infinity. Then I look at the right side. As x goes towards positive infinity this way, what is my y values doing? It's also going up, so it's also going towards positive infinity. So that is just extra information, extra practice. But if you have any questions over anything we covered in this video, and I know it was a lot, please write them down and make sure you ask in class.